Hello, Honors Chemistry, and welcome to the reaction summary. Watch this real quick before you jump onto the mixed practice. So, obviously, before you do the mixed practice, the key thing is you need to be able to identify what kind of reaction is it. So, what to look for, right? If we were trying to identify a precipitation reaction, what would we be looking for? Right, we'd be looking for two aqueous ionic reactants. And if we have two aqueous ionic reactants, we will, switch the cations. And then, in terms of things to consider on the product side, we will think about solubility rules. And that solubility rules are going to tell us whether or not it's a solid or if it's aqueous, and whether or not we actually have a precipitate, or if it's a no reaction situation. If we have an acid or a base, which we'd recognize because we would have an acid plus a base, which is a metal hydroxide, going back to our definitions. And what are we going to do? We're just going to switch the cations. And after we've switched our cations, we ought to have water and a salt, where salt just means, correct, ionic compound, gas evolution, we have a few options here. We might have an acid plus a carbonate, or a sulfite, or a sulfide, which is going to give us, it's going to give us a gas and water and salt. And the gas options are going to be H2S or SO2 or CO2, depending on what we start with, Alternatively, we could have a base plus an ammonium compound, and that's going to give us an H3 and water and salt, So again, what we're doing is we're summarizing what to look for on the reactant side. Think about, what should we think about when we see those reactants, and then what should we get on the product side, And don't forget that all of these, are based on the fact that we switch cations. We switch our cations, And then there is an intermediate, And that intermediate is what breaks down one more time. And that's how we do our gas, Then we have combustion reactions, which would be CH or CHO reacting with oxygen to give us CO2 and H2O, Those are pretty simple, and I organized this weird and wrong. Combustion really should be a subset of redox, but it's fine. The oxidation reduction reaction we talked about the other day would be if we had two elements. We could take those two elements and form a compound, because there's nothing else to do with just two elements, There's just not any other options, And I said we would expand a little bit on oxidation reduction next time, and it is next time. So we just talked about this, So if I have two elements, the only option is to produce a compound, okay? Now, if the reactant is a binary compound, so if I just have a binary compound, and what does binary compound mean again? Only two elements, And my question could say something like, this compound is decomposed, or broken down, or typically decomposed. But if it's a binary compound that is decomposed, it's going to give us, you guessed it, two elements, Because if it's only made of two elements, there's no other option, There's no switching, there's not another reactant. So all it's going to do is break down into its respective parts, And then finally, we could have an element and a compound, So if I had an element plus a compound, then the element switches with most similar part of compound. The element switches with the most similar part of compound to form a new element and a new compound. So, for example, right, we could have sodium plus magnesium chloride, right? And we would say, oh, there's an element, there's a compound. The element, sodium, will switch with the part of the compound it's most similar to. And between magnesium and chlorine, sodium is most similar to, right, magnesium. If we look at a periodic table, we would be able to see that, these are both metals. And if we zoom out a little bit, they both play the role of cation in ionic compounds, right? So those two would switch. If they switch, that means the new element is going to be magnesium, and our new compound is going to be sodium chloride. All right, go ahead and have at that mixed practice, and the key will go online or be in Schoology. All right, be good. Have a good day. Bye.